So you have drawn the 3 points, you have joined the points to have a rough idea of what the plane is. But to find the Miller index, what is the definition for Miller indices? They are the intersections of the plane with the 3 axes. Where does the plane intersect the x-axis, the y-axis and the z-axis? You find these 3 points, the intersections of the plane with the 3 axes. Then you can find the Miller indices. So yeah, you see, if you have this plane now, you have this plane, it intersects here. So it intersects one axis here. It intersects one axis here. But if this is the point, then this point is in the middle. This is not intersecting any of the axes. Right? So one intersection is here. One intersection is here. But the third intersection is not there. So this is a correct plane line. This is a correct plane line. But extend this line, make it a straight line until it hits the other axis. Right? So this is important, that you go to this point D. Now this from A to C to D, this is the full plane now. This is the full plane because it intersects one axis here, and the other axis here. So this is now your complete plane. This is one thing. Earlier when you were from here till here, then you have partial plane. It is the same plane, but it was partially there. When you have extended it and it hits it here, then this is the whole plane. So now you just find this intersection, right? And you find this intersection and you find this intersection. So if you will see, you see, you have gone x1 and this is half of z, right? And so on, isn't it? So this is now the plane. So this is the plane, and what you do is you make this as your origin. You make this as your origin so that you can define all the points very easily now. If you still take this, then there will be an issue. It will be on the z-axis itself, right? This is the z-axis directly, so there will be an issue. So if you move your point here, this is the origin, new origin, and then you find the points. This is the new origin, right? This is the new origin, right? So therefore now on x, you move on x line. This is your, no, sorry, right? This is your x line. I'm very sorry. This is your x, this is your y, this is your z in the original coordinates. So from here, this is your x, this is your y, and this is your z. So you go x, so therefore this intersection is at -1, right? You go on y, this intersection is at half, right? You go on z, this intersection is at -half, right? So therefore, right, for x -1, for y half, and for z -half. Okay? So again remember, if this is your origin, plus x is here, minus x is there, right? Plus y is here, minus y is there, plus z is there, minus z is there. So from here, -1 on x, plus half on y, minus half on z. So these are your original intersection points. To find the Miller indices, you take the reciprocals of these, 1 upon x, 1 upon y, 1 upon z, right? First find the intercepts, and then, so 1 upon x is -1, 1 upon y is 2, 1 upon z is -2, right? This is it. So you have found the intercepts and you have done the inverse of that. So -1, 2 and -2, these are the Miller indices. So finally you write 1 bar, 2 and 2 bar. These are the Miller indices. Okay. So it was a slightly interesting example compared to your normal ones because the intercepts were not directly given. Points were given, points on the plane. So you draw the points and you join the points and see that this is the plane. Now, if when you join them, they already cut all the three axes x, y and z, then you can directly find the Miller indices. But in this case you found that two of the points cut the axes, but the third point did not cut the axis. So you extend the line until it cuts the axes. Once it is there, then the whole plane is there. So this is the whole plane, and you have found the intercepts here and here and here. You find the intercepts, you invert them, and you have the Miller indices. Okay. So again, if you understand this very well, 100% correctly, then there is very little left in Miller indices and planes and so on, which you can't do. And this knowledge is important to understand the crystal structure, and this knowledge is important in understanding any materials like metals and alloys and ceramics, which is crystalline in nature. Let's go to the next question, 6a, according to our numbers. Values of atomic mass, density and atomic radius for a metal alloy are 43.1 gram per mole, 6.4 gram per centimeter cube and 0.122 meter respectively. Mass, density, atomic radius are given. Determine whether its crystal structure is FCC or BCC. Show all calculations and give reasons for your answer. Right? So it is FCC, it is FCC or BCC. And the values of the mass, density and radius are given. You have to find out whether it is FCC or BCC. So it is very simple. Assume that it is FCC, find its density. Density is mass per unit volume. So it is the mass of the atoms in the unit cell divided by the volume of the unit cell, right? Basic definition. So do this for FCC. If the density that you find is the same density as given, 6.4 gram per cubic centimeter, then it is FCC. Then you don't have to do further. If your answer is not right, you assume that it is FCC, find the density, but the density is very much different from 6.4, then it is not FCC. Then now assume that it is BCC, find its density, and now if the density is very close to 6.4 gram per cubic centimeter, then this is it, right? So this is it. And when you do the density, the distances will be nanometer, right? And grams will be there because the atomic mass is in gram per mole. So you have to convert the nanometers to centimeters so that you can have your answer in gram per cubic centimeter. And if you remember that because the atomic mass is given as gram per mole, so you have to know the Avogadro's number, which is number of atoms per mole, right? So that is there, and then you can solve it. So again, you solve it like every other problem. If you want to do real practice, solve it again before going to the solution. Solve it again, be very sure, and so on. So you know that volume density of a metal is mass of the atoms divided by volume of the cell. Mass of atoms is the gram per mole value divided by Avogadro's number, because Avogadro's number is atoms per mole. So gram per mole upon atoms per mole, mole cancel away, you get gram per atom, right? So for the mass, gram per mole divided by the Avogadro's number. BCC, you have 2 atoms per cell, and the volume of cell is always A cubed, and for BCC, A is 4R by root 3, so 4R by root 3 cube. So you just put these values here in the definition. 2 atoms in the unit cell, mass of 43.1 gram per mole is given. 6.023 into 10 raised to 3 atoms per mole is the Avogadro's number. 4R upon root 3. 4 is there, root 3 is there. R was 1.22 into 10 raised to minus 8. It was given, right? Here we have directly converted it to centimeter. It was given as nanometer, but if you convert it to centimeter, then now everything is gram and centimeter, right? So this is the only thing. 2 atoms, mass of 1 atom, Avogadro's number, 4R by root 3. So 4 root 3, R already changed from nanometer into centimeter. So now just solve it. It comes out to be 6.4 gram per cubic centimeter. And this is the same value as given, right? This is the same value as given in the problem. So it means that the material that is given to us has a BCC structure. So if you had directly tried BCC, this would be it. If you had tried FCC first, your answer will be some other number. So then you will say that this answer is not matching. So let us try BCC now. So, right. So this is the way you solve this problem. The second part of this question 6b, XRD is performed on FCC nickel. So it is known that nickel is already FCC. Atomic radius 0.1246. So the atomic radius of nickel is also given. Using a monochromatic radiation of wavelength 0.1542. So the wavelength lambda is also given. For which set of crystallographic planes will a first order diffraction peak occur at a diffraction angle of 44.53 degrees? No, so the diffraction angle is also given. Remember, this is 2 theta, right? Diffraction angle is 2 theta. It goes and it comes back. So it is 2 theta. So the theta is half of this. So which crystallographic plane, 111, 000, 121, which plane, for which plane this happens? For which plane this happens, right? So if you have solved it very correctly, okay. Otherwise, solve it again. Go to the diffraction part of the course, solve it again. If it is very clear, do it for you, do it for yourself. And once you are sure that you have solved it now again as a repeat problem or earlier, then go and look at the solution. You know the process. There are only 2 equations that apply to this part of diffraction and so on. DHKL is A upon H squared plus K squared plus L squared for interplanar spacing, and N lambda is equal to 2 DHKL sine theta. We are not writing the N here because the first reflection is from the initial plane, so N is equal to this. So this is it. These are the 2 equations, right? And then you solve it. So if you combine from here, DHKL is N lambda upon 2 sine theta, right? N is equal to 1 because we are taking reflection from the first plane. Lambda is given as 0.1542. 2 is there. Sine theta is the angle is 44 divided by 2. So DHKL is found to be this much. We also know from here that H squared plus K squared plus S squared is A upon DHKL, right? A upon DHKL. And because it is FCC, so A is equal to 4R upon root 2 or 2R root 2, whatever you want to say. 4 upon root 2 or 2R root 2, and DHKL is there. So now this 2 is there, radius is given 0.1246, root 2 is there, and DHKL we found to be 0.2035. So H squared plus K squared plus L squared is 1.732, right? 1.732. So this was root of this. If you square this number, a square of this is roughly 3. So H squared plus K squared plus squared is roughly 3. Now remember, right? We know that for FCC, what was the rule? So for FCC, what was the rule? That reflection will be there if the Miller indices numbers HKL are all odd or all even, right? So all even, you start for 0, 0, 0. Their sum cannot be 3. You go to 1, 1, 1, 1. So 1 square plus 1 square plus 1 square, is it 3? That is it. It is 3, right? So you have found the sum of H squared plus L squared plus K squared. It comes out to be 3. And because nickel is FCC, it is given. And for FCC, either all are odd or all are even. So all even, you start with the lowest number 0, 0, 0, 0 plus 0 plus 0. No. 1 square plus 1 square plus 1 square is 3. So the plane is 1, 1, 1. The plane is 1, 1, 1. So this is the answer. Okay. Thanks a lot for being with us. And hopefully I'll see you in some other course or other things. Ma'as salam.